All right, this leads us to example 4a, where I have some more dividing happening, but we have a little bit more work that we'll have to do here. So in example 4a, my problem is the cube root of 7x over the cube root of 5y squared. Now, I have a couple problems here. My first situation, I could, in theory, write this as one gigantic cube root, like what we did up here. In example 3a, we took our original problem and wrote it as a gigantic square root and simplified. 3b, if you watched that one, we had the cube root. We wrote as a gigantic cube root and simplified before. But in example 4a here, even if I did that, my 7 over 5 couldn't simplify. I have an x on top, y squared on the bottom. I'm not going to be able to simplify. My second problem is that I can't have my cube root in the bottom here. So I have to do something in order to rationalize my denominator. Okay, so if I look back up here real quick, when I had 1 over the square root of 2, we multiplied by the square root of 2 on the top and bottom. Down here, we're going to do a similar process. We just have a cube root instead. Okay. So we have to figure out, what do I need to multiply by? I'm going to have to multiply by the cube root of something on top and on the bottom. And these somethings need to be the same. Now I'm going to write my problem like this for a second and think of what I want to ultimately have in the denominator here. I ultimately want to be able to cube root something with a 5. So it would be nice if I had 5 to the third power underneath. It would also be nice if I had y to the third power here. This is what I want to get, because then I could cube root 5 to the third and get 5. I could cube root y to the third and get y. So really I want to make each of these parts to have a power that's a multiple of 3. So 3 is a multiple of 3, 3 is a multiple of 3. All right, so this is what I want to have on the bottom. Let's figure out, what do I need to multiply by in the middle to get there. I have 5. I want 5 to the third power. So I need to multiply by 5 squared in the middle. I have y squared. I want y cubed. I need to multiply by another y. So just to double check, my 5 times 5 squared is 5 cubed. Y squared times y is y cubed. Need to multiply by the same thing on the top. So cube root of 5 squared y. Right, so to keep going, we're actually almost done now. My index is the same. I have cube root both. 7 times 5 squared, 7 times 25, is 175 x, y. The only other thing we'd want to check, is there anything we can do to simplify this cube root of 175? And if you like looking at your power table and thinking that way, my perfect cubes, well, 175 divided by 8 doesn't work. 175 divided by 27, no. 175 divided by 64, nope. So this would really be my final answer, the cube root of 175 xy over 5y. And I don't need absolute value anywhere because I had a cube root.